this meeting on 3-2. We're going to go over the quiz. Okay, so if everyone has the quiz open, our first one is the symbol for the true population proportion is which of the following?
I'm pretty sure it's just normal P.
Yeah, I think so.
Okay, for the next two questions, suppose n equals 100, p equals 0.25, and party hat equals 0.10. The requirements for constructing a confidence interval are satisfied.
Let's see. I'm wanting to say yes.
N times P hat has to be greater than or equal to 10.
Yeah, that's what I'm looking for right now.
Yeah.
That looks true. It looks like it equals 10 exact, or
Yep.
yeah, it equals 10 exactly.
Yep, it equals 10 exactly. So true. The conditions for conducting a hypothesis test are satisfied.
And that one's n times p is greater than or equal to 10. So I would say yes.
For the confidence interval, it has to be either of the two requirements, and for the hypothesis test, it has to be both of them.
Oh, it does have to be both.
Yeah.
Okay. Well, 1 minus p would put us at 0.75.
Times n, which is like way over.
Yeah, it's 100. So that would put us at 75.
So that's true as well.
Yeah.
Okay, we use the following. A study of first-degree murder trials was conducted in another state. A random sample of 60 people on the trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Find, party hat, the point estimate of the proportion of the first-degree murder defendants who are found guilty in this state.
Nothing funner than first-degree murder.
I'm glad they gave us a light note to do this quiz with.
Yes.
So p hat equals x over n.
So 45 divided by n. Or 45 divided by
60.
So that'd be 0.75.
0.750. A 95% confidence interval for the true population of the first-degree murder trials in the state where the verdict is guilty. Input your answers for the margin of error, lower bound, upper bound. Are we going to use a nifty spreadsheet for this?
I don't think so. I think that since there's not like the data, it's just like the base numbers. Like there's no I don't know what the right word is, but we don't have like the actual numbers themselves. We just have the variables that I don't think we can use a spreadsheet.
Well, if we do the category,
unless it's just like a spreadsheet you made yourself that has formulas.
Well, no, Mitch, do you want to download this one and see if it's the one we want to use? It's the categorical data analysis hat spreadsheet in that.
Oh, baby, where is that at?
That's the last one in the page that I sent out. The link. Pretty sure we can use this.
Hey guys.
Hi.
Hey, how's it going?
Sorry,
Any
I'm
idea
late.
what day you sent that on?
I'll just copy and
emails.
paste it. Here.
Sorry.
Oh, that's okay.
I downloaded the two that we like usually use, but I didn't save the page that has that list of them.
I'll put it in the chat.
Well, geez, Mitch.
Yeah, I'm bad.
Okay.
What's your problem?
Oh, there it is. Okay.
I bookmarked it because I figured we would be using it.
I'm not that intelligent.
I'm pretty sure you are.
Okay, there we go.
What do you think? Okay, so the null hypothesis, I'm not sure.
Okay, but we know X and N.
Yep, we know X and N. So I have to go back this weekend and study all confidence intervals.
Is it the confidence interval on the bottom where it's 0.64 and 0.86?
That's what I have.
That seems reasonable.
But I have it greater than. It doesn't change.
It's like if you change it, it doesn't matter.
But
Wonder
if you
change the whole null hypothesis, if it matters. It doesn't. It doesn't matter if you change the null hypothesis either.
Okay.
no, so
Cool.
0.64.
Determine the margin of error. So that would be 0.11.
Yeah, so the lower bound is 0.64 and the upper bound would be 0.86.
You have to put the zeros, or is just 0.64 good?
I think we're supposed to round all the way. I don't know.
I mean, like when you submit it, it gets rid of any zeros on the end, anyways.
Yeah,
I
I'd noticed that, but I'd hate for it to just be
I'm
a
not gonna
display
risk
issue.
it.
Because I mean, they could evaluate based off of the 3 decimal points and then just display 2.
So your margin of error. Let me see. Oh, so you just subtract it.
0.11. Yeah, you just take the mean and you subtract the upper bound, the mean from the upper bound. And the mean was the 0.75.
What was the upper bound?
0.860.
So if you increase the sample size from 60 to 80, what do you expect to happen
I would expect it to
with the confidence
decrease,
interval?
Decrease.
because it would be closer towards the mean, right?
I'm pretty sure.
I
Well,
just
look
changed
at it. Look at the spreadsheet. If we change it for 80,
Yeah, I just changed it to 80, and the confidence intervals are now 0.454 and 0.671 as lower and upper bounds. So let me run that real quick. 0.61 minus 0.45. So the margin of error is now 0.1085. So yes, it would decrease.
what was your confidence interval?
The lower bound was 0.454
Okay.
and the upper bound was 0.671.
Okay. Okay, next question. To conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose P equals 1/2. What is the smallest N can be and both requirements still be met? Okay, how do we do this one?
I'm looking to see if there's a better formula.
Where is this formula in here?
Sorry, I'm back.
All right, you're good.
Did we figure out 11?
That's what we're doing right now. I was looking to see if there was a better formula.
Okay, so if P is 1/2, We have to fulfill both requirements. They should be the same at 1/2, right?
Yeah.
Where are those requirements? Right.
Has to be.
N times P has to be greater than 10. So if P is 1/2, N would have to be 20, right?
Yeah.
This.
Let me make sure that that works on the other one too. Yeah, it's exactly the same. Okay.
Yeah.
10 seconds.
So suppose P equals 1/10. What's the smallest N can be? In that case, it would have
This
to
one,
be.
it would be different.
Yeah. So we just have
N
to.
times P would need a higher N. And so you would need 10. You'd need 100.
You need 100. So right now,
The
100s
other
are.
one, you would only need 10, right?
Let's see.
So this would be.
Oh, wait, no.
So
If you did
N
the other
times
formula-
0.9.
You would need like 11 point something. You'd get 10, you'd only be at 9. 11, you'd be at 9.9. And then you need slightly more than that.
Yeah. So let's
But
just.
that one, it's irrelevant because the
Yeah.
smallest N can be is 100.
Yeah.
Wow, this is going really quick. We only have like 4 left,
Oh.
6 left.
Use the information for the next 6 questions for the water quality study in the reading. About 60% of the microinvertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using a significance level of 0.05 with the following hypothesis. HOP equals 0.6. HA is P is less than 0.6. They collect new data this time. N equals 80 and X equals 38 indicate good health. The conditions for conducting a hypothesis test are satisfied.
I would say that's true.
So 80 times 0.6.
I think it would actually be 80 times 0.4 because since it's higher than 0.5, we would use the 1 minus P times N.
Mm-hmm.
Okay.
But it's still much higher than 10.
So 1 minus P times N. 32. So true.
And then P would just be X over N. 38 divided by 80.
Divided by 80. Gives us 0.475.
Yep.
Okay. Test the statistic. This is where we could use the spreadsheet possibly.
Test statistic. Okay, so X is 38. And 80 confidence level is 0.5. No hypothesis is 0.
Well, the level of significance is 0.05. The confidence level would be 0.95.
Yep, 0.95. And then the type of test is less than.
Null hypothesis would be 0.6.
Yep. So is our test statistic the z-score?
That's a good question.
Yeah, that's a great question.
Should we try it?
I mean, it makes sense to me.
I think that is the test statistic.
I don't see what else it would
Sure. I mean, unless it was like the area or something, but
be. 282. You know what we can
Negative
do?
2.282.
Test statistic. This test statistic is Z.
okay. Deal. And the p-value is 0.011.
Perfect.
Yeah, our handy dandy Excel sheet.
And we can reject the null hypothesis.
Yes.
There is sufficient evidence to conclude that the water quality has decreased. I don't actually know. Let me go
Yeah.
read up.
It would be has decreased because that's what we're looking for, is to see if it's gone down.
Yeah, if it's less
And the
than.
null hypothesis is that it hasn't changed.
Okay.
So, okay, I'll go ahead and submit.
Says it's less than. If P is low, reject the null. Yep. There you go.
100%.
Thank goodness.
Boom.
Yes.
That was so fast.
Spreadsheet.
Can we go over the? I missed like the first half.
Yeah, you bet. Which question should we start on? 3?
Yeah.
Sure.
For 3, the true population proportion is symbolized by the normal P. There's no extra symbols. It's just P.
Okay.
4, the requirements are satisfied, so it's true. And the requirements for hypothesis test are satisfied as well, so that's also true. P hat for 6 is 0.75. All we did was divide 45 by 60, x
Okay.
over n. And then question
and
7.
5 was false.
5 was
5 was
true.
true. 4 and 5 are both true.
Gotcha.
7 is the margin of error is 0.11.
Okay.
The
and
lower
then
bound is 0.64,
4,
and the
okay.
upper bound is 0.86. Oh, you got it. Sorry.
Yeah, and then 11 and 12.
11, we got 20
Okay.
because we were saying that if P is 1.5, in order to get to 10, we would need 20 at 10.
Mhm.
And then for question 12, we got 100.
Sweet. Sorry about that.
No,
No,
you're totally fine.
Sorry
Okay,
if
I
I
was
sound
gonna
all
ask.
gargled. You guys probably wouldn't believe it, but I'm sick again.
Oh,
Ouch.
you need to get Mitch. I think you need to get some colloidal silver.
I swear I do not have an immune system. It just doesn't exist.
Do you take airborne?
Do I what?
Take airborne? Have you tried?
I don't know what you mean.
Have you tried airborne? Have you ever heard of this?
Is that like a medication?